my name is Lokesh. Today our topic is three topics: dielectric constant, capacitance by bridge method, and third one is applications of ferroelectric materials of BSc first year or BTech first year. Let us start the video now. Let us go to dielectric constant first of all. First topic, dielectric constant. What is dielectric constant? Dielectric constant. Let us go to the topic. The ratio between, it is defined as, okay, first of all, it is defined as the ratio between the capacitance of a capacitor in dielectric medium to same capacitor in free space or in air medium. Here we have formula ER epsilon R equals to C1 dash by C1. Here C1 dash equals to capacitance of a capacitor in dielectric media. What medium? Dielectric medium. Okay, my friends. Next we'll go for C1. Means the capacitance of a capacitor. Same we write as capacitance of a capacitor which is in free space or in air medium. What medium? Air medium. Okay. This is the first topic. We finished it. Now let's go for another topic, that is bridge method. Let's rub the board. Sorry, my friends. Oh, our issue. Don't have proper understanding. Let's do it. Okay. Now let's go for another topic. What is first topic is completed. Now next topic is capacitance bridge method. What is capacitance bridge method? Let us see now. Capacitance bridge or coordinates bridge method. Let's go for that. Okay. Now it is to measure the accurate value of capacitor or permeability. Okay, relative permeability or dielectric constant. Okay, let's go for it. We have a diagram for this. A galvanometer connected to the center, and we have a resistor, and we have a capacitor, and for the capacitor we need to connect a resistor. Next we need to connect a resistor as well as, let's draw there. We have some issue of board here. Let's draw there. If you don't have proper board, don't worry, I don't follow. No problem with that. Let us draw a side by side. Small G galvanometer and a capacitor resistor here, and a capacitor and a resistor by both. Here we have it, both are connected. Next we have a capacitor. First we have a resistor, we have a resistor for this and a capacitor to this. Now we have a capacitor, that's all. Now let's name it. R1, C1, C2, R3, R4 and C4. Okay, this is G. I want to erase now. Slide a small one. Slide a small one. That is G. Okay. I want to name this one. First one, R1. Resistance, a series resistor representing loss of a capacitor. Next, C1. Capacitance, we need to find it. Next, C2. Standard capacitor or standard capacitor. Next, C4. We have variable resistor or non-inductive something we write R1. We'll go from step by step. R3. Non-inductive variable resistor. Next, R4 we write as non-inductive resistor. Next, we will write the C4. C4 means capacitance, which is variable capacitance. Variable capacitor. Okay, these are the names. We have a G here. Galvanometer. Okay. Next one we have S. High frequency oscillator. Okay. For this, all of you know that. Next we go the derivation part. Okay. Let's go for it. Another one I forgot to say that the resistance of capacitor is 1 by j omega c. It is represented here. That next step we'll see it. Okay. I want to rub it. Let's see. I want to rub it. Sorry, I rub diagram. No problem. Okay. So I will draw the diagram again. One stick out. This is R1. This is C1. This is R2. Okay. No problem in that? I think so. It's C1. Okay. I take under chart, right? Now, P equals, here we have resistance of capacitor. It is general 1 by j omega c. Okay, this is C. P. Now we have 1 by j omega c1 plus R1. Now to be, this is R. Next, Q equals to, this is P, this is Q, this is R, this is S. We have a basic formula, E by Q equals to R by S in this method. Okay. Next, Q equals to R cube. Now R equals to 1 by j omega C2. Next, 1 by s. Why I am as a next step I will write 1 by s. Now 1 by s equals to 1 by, here we have two, no, they are in parallel. 1 by r4 plus 1 by c4. I will derive here. Once check it out. If I am wrong, can you tell me in the comment box? Okay, no problem in that. If you have any doubt, you can comment in the box. Now 1 by s equals to 1 by r4 plus 1 by c4. Here I think so 1 by j omega c. No. Let's check it. Okay. SC 1 by s equals to 1 by r4 plus 1 by 1 j omega c4. Let's go it up. 1 by s equals to 1 by r4 plus j omega c4. 1 by s equals to 1 plus j omega c4 by r4. Now s equals to, reverse it, r4 by 1 plus, here it means c4, and I think here we get r4 also by LCM. R4 I think we get, r4 also, maybe I think so we'll get it. Here I can don't get, but here we get here r4 1 plus j omega c4 r4. I'll write here and top corner. I think so. Yeah, I'll write again next step. Wait. We have the whole problem. We are coming on with the, I think we are here 1 by 1 plus j omega c4 r4 by LCM r4 by LCM next r4 is equals to 1 plus j omega c4 r4 by r4. Up to here we have clear vision. Next we go for the derivation part, that is main equation part. Let's have a drop this. Once take a note or take a screenshot. No problem. Okay. Chalaram. Okay. Okay. Let's take it. Okay. Let's take a while now. Next, we'll go for this. Now we have noted P by Q equals to R by S. It's our original method. Now, 1 by j omega C1 plus R1 divided by R cube. This is the 1 equals to R means we have R cube, not R cube. 1 by j omega c2 by 1 plus, sorry, r1 by the, so we have r4 by 1 plus j omega c4 r4. Okay, now let's make this happen. Now we have cross multiplied it. We have R3 this side and R4 this side. R4 into 1 by 1 j omega c1 plus R1 equals to, what was this line? I want to come here, and R3 into, okay, what is there? 1 by j omega c2 divided by 1 plus 1 by 1 plus, I think so. 1 by 1 plus 1 by 1 plus j omega c4 r4. Okay. Next step we will continue. Okay. Up here we have a clear option. Cross multiplied, and we are taking a cross multiply r this side, r4 this side, and this may come this side. Okay. Now let us multiply it. R4 into R1 minus of J omega C1 by, not like that, J R4 by omega C1 equals to, now we have R3 into R4 into C4 divided by C2, okay, into minus of J R3 divided by omega C2. Now, by comparing real coefficient, real terms and imaginary coefficients. Okay, now I want to rub this all. So I want to rub it. Let me rub it for a while of second. Couple of seconds. Okay, now we have it. Let us compare. R4, R1 equals to R3, R4, C4 by C2. This is the one part. Next part, we have what part? This one. Minus J R4 by omega C1 equals to minus J R3 by omega C4. C2. That is C4. No, C2. Now, J omega minus and gets cancelled. J omega gets cancelled. Now, we have it. R4 by C1 equals to R3 by C2. Now, we have C1 equals to R4 by R3 into C2. Now we got the capacitance of first whose we need to find. We got C1 value. Now we need to find the same value of C1 dash. Approximately the same value will come C into C2. Okay, this into C2. Now let us make a ratio of dielectric constant. This is dielectric constant. Okay, this is C1 dash. The gap will be there. C1 dash. Now let us K equals to R epsilon R. K epsilon R equals to C1 dash by C. We get the value of R4 by R3. R4 by R3. R4 by R3 into C2. R4 by R3 into C2. Now let us take it. We'll get same value. So no problem. We'll just make a ratio and we'll leave it there answer. Okay. We'll make a and we will leave it. Next, here R3 will be different in both the media. I want from this. Here, I will write here. So no problem. No problem there. Next, R3 equals to, here we are in starting we write non-inductive differs. R3 value differs in both the media because R3 is non-inductive variable resistor. Okay. Next we go for another applications of ferroelectrics. So I want to say one thing. Ferroelectrics is a So they have many applications like memory cards, and another one they you can be used as small sized high capacitors and memory cards, computer drives, and microphones. Next we can use in what we can use here. Uh, in piezoelectric method, in ultrasonics we can use it mainly for generation of electricity in there. Optical communication also we can use it. Mm, next we can use etc. There are many uses. In some I know. I said that. So we are completed our session. Thank you. Bye. If you have any doubts, you can comment in the chat box. Please subscribe the channel and add a like button. Thank you. Thank you one and all.